Hello, period 7. This is your special makeup video here for the day we lost. And this video is not going to be too long. I mainly just have to show you domain and range because when we left off in class, we were just finishing, or starting, I should say, the real life situations, and I had you fill this in. We'll discuss those in class on Monday, but I want to get the domain and range done now. So domain and range are terms you've probably used before. Domain is the set of all possible values of, you're used to saying x, your input or first variable, whereas the range is the set of all possible values of the second variable, typically y. So I'm going to do 2 or 3 graphs with you, and then I'm going to have you do the rest here. And then we'll check at the end. So what I want you to do is, I hope I gave you a half sheet of paper that has, I think yours has 5 graphs on it. So go ahead and get that. It should be taped in your notes. And on the first graph, what I want you to do is draw the following shape. It goes down to 0, -4, and then it increases like this. And then just make it have a curve that looks something like that. It doesn't have to be perfect. So we want to get the domain and range of this. Now to state the domain and range, we're going to start with an inequality notation, and then we're going to move to a new notation called set notation. So the best way to think about domain is to just run your finger or your pen or pencil along the x-axis and think, does the graph have every single x value hit? And does the graph have every single x value hit to the right as well? So all the way to the left, all to the right. Or you could think, are there any restrictions on what x could be? All of these x values have y values that go to them. And you might be thinking, well, it ends here. But that's just because my graph stops. It keeps going up and to the left forever. So all of these x values, all the way down there, all the way forever, keep getting mapped to y values that are way, way up. Same thing to the right. As I keep going to the right, it keeps getting mapped to y values that are increasingly larger. So if it goes to the left forever, and it goes to the right forever, there are no restrictions. So what you want to do is think, what's the smallest value that x can be? And if I go to the left forever, well, that would be -infinity, and that's an infinity sign. And if I go to the right forever, the largest x value that it could get would be infinity. So I'm going to trap x in between -infinity and infinity. That really means every real number is a possible domain value. I don't put the equal sign under because you can't include infinity. Infinity is an idea, it's not a number. Now let's think of the range. So for the range, I'm going to run up and down the y-axis and think, does this graph go up forever? Does this graph go down forever? Now this graph clearly does go up forever. Every y value to the top is hit all the way to infinity. The graph, however, does not go down forever. The lowest y value is right there, which is -4. So you start with the lowest y value. Now -4 is included, so I put an equal bar, and it goes up to infinity, meaning it goes up forever. Now this is probably how you would have written it in like 8th or 9th grade, but I want to show you something called set notation, which is how you would see it written in upper level math. So starting in like calculus and upwards. So set notation, write this down somewhere, is a more precise way of writing sets of numbers. And for set notation for domain and range, what you're going to do is you're going to use parentheses or square brackets. If you put parentheses by a number, that means the number is not included. And then if you put brackets by a number, it means the number is included in the domain or range. Now you can have all kinds of combinations, like you could have parentheses and then a bracket, or a bracket and then parentheses, or 2 brackets and 2 parentheses. Those are the 4 combinations you can do. What you put in these parentheses are the following. You always put the smallest possible number first, followed by a comma, and then the largest possible number next, followed by a parentheses or bracket. So smallest number, largest number, always. So let's go and do that for this one here and see if we can get it. Now, here's the thing with infinity. You can never include infinity, so you're always going to use those parentheses for it. Because it's an idea, again, it's not an actual number. So for the domain, I would open up a set of parentheses because I can't include infinity or -infinity. That's the smallest it can be. I'm going to put a comma, and the largest it can be is infinity, and I'm going to put parentheses again. For the range, The smallest number that y can be is -4. I'm putting a bracket by it because I can include it. Then I put a comma. Then I put a parentheses with, then I put an infinity with a parentheses because I can't include infinity. It's the largest that it can be. So now what we're going to do is try another one. And for this one, I want you to make a semicircle with a radius of 3 and draw it like this. And I want domain and range again. So for domain, I'm going to take my pen or pencil and go left and right and see, is there any restriction? Is there anything x can never reach? Now these closed dots mean that these values are included. All the x values in here have y values that correspond with them. But the graph doesn't go right forever. It stops right here. The graph doesn't go left forever. It stops here. It's very restricted. The smallest that x can be is -3. I'm including it. The largest x can be is 3. For the range, I'm going to go up and down and see, does it go up or down forever? Clearly not. The highest up it goes is here. The lowest this graph goes is right here, and that corresponds with that point and that point. So start with the smallest y. The smallest y is the y value that corresponds right here, which is 0. It's included because there's closed dots there. And the largest that y can be is this point right here, and that's 3. So let's write set notation for each here. I'm going to put brackets because -3 and 3 were included. Smallest number, comma, larger number. And then for range, let's do set notation. Smallest number, comma, largest number, brackets on both because they're both included. So you might be thinking, well, is infinity the only time I use those parentheses? And the answer is no. So let's try an example like this. Go to -2, 5, put an open circle, and just have a graph that does something like that. So open circle means that as I move this way, all these points are hit up to, but not quite including the point -2, 5. -2, 5 is not included in the graph, but just before it, like -1.9999999 is included, and 4.9999999 forever is included. So for the domain and range, I want to see, okay, I'm going left and right here. It doesn't go left forever. The furthest left this thing moves is right here. And the x value that goes with that is -2. But -2 is not included. So to indicate that I go all the way to -2, but not quite -2, I'm going to not include -2. And does the graph go right forever? And the answer is yes, as it moves this way. So I'm going to put infinity. Not included. Now let's do the range. Does the graph go down forever? Does it go up forever? Well, it does go down forever because this arrow means down and right. So the smallest y value I get is -infinity. And does it go up forever? Nope, this is the highest it goes. The y value that corresponds to it is 5, but I can't quite include 5. Now some people are tempted to say, well, what if I did this? I include -1.9 and then I go to infinity. Well, the thing is, what about -1.99? Then you'd have to put another 9. But then the thing is, could it be -1.999? And you keep adding 9s. And then people are like, oh, well, what if I just put this bar here? I mean, technically, you maybe could do that, but a way more concise way of doing it is just to say this. You could also say it like this. That is the inequality method of writing this. All right, so I'm going to give you 2 graphs, and then I want you to try them, and then I want you to come back and check your answer. So make sure you're okay so far. Here are your other 2 graphs. I want you to pause the video and get these written down. This right here, I've shown you a graph somewhat similar to that when we first started functions. This is actually a sine wave, sine of x, and you should assume that it continues this pattern forever to the left and the right. And this one here is a scatter plot, but remember, try and think of that vocab word I used to describe this for what kind of function it is. And hopefully you're thinking, oh, that's a discrete function. So plot that and give me the domain and range for each, and then come back and check it. Make sure you actually try it on your own, and then check it. All right, let's see how you did. So since this graph goes left forever and then right forever, my domain is negative infinity to infinity. Now this graph does not go up and down forever. The lowest it goes is here. The highest it goes is here. It does include negative 101 because it actually hits those points. So I'm looking at this or that. Now for this one here, discrete functions, remember I showed this to you when we first started function notes. If you forgot it, I'm guessing you wrote it like this and like this. This is bad because what this means is every number between -4 and 6 is possible. But that's definitely not true because then that would mean every number between here and here would have a y value. But look, none of these x values have y values. It's only those certain exact ones that I list right here. Similarly, -1 to 3, you can't include every y because not every y has an x that goes with it. Just these 5 specific y values. Okay, so this will hopefully help you do that homework half sheet on domain and range. Do it in set notation. You can also do an equality notation, but I really want you moving towards set notation. And then don't forget your bookwork and the correlation video as well. Okay, so have a wonderful rest of your weekend, and I'll see you Monday. Bye-bye.